In this, second one will be as what is Raoults law. The next, what is deviation of Raoults law for the ideal solution. And third will be as colligative properties. So if these three topics, if I completed, the liquid solution chapter is over. The first one. So what is vapor pressure? Take the example. I'm taking as, listen, let us take this is the container which has, you can take this is a liquid, this closed container, alright. So obviously this is surface area. Obviously the liquid tendency to escape from its the vapor state. Now I can see that here that the liquid which is in the vapor state, liquid which is in the vapor state. Now this is liquid. Now liquid which is this is in the vapor state. Now at equilibrium. Equilibrium means what? Rate of evaporation is equal to rate of condensation. At equilibrium, at constant temperature, the vapor, this is vapor, the vapor exerted pressure is called vapor pressure. At equilibrium, the vapor exerted pressure is called a vapor pressure. Now the question is, to this, if I am going to add as what? Non-volatile solid. To this, if I am going to add the non-volatile solute, very less quantity if I am going to add. So this is liquid is a solvent plus solute which makes solution. Look at this. Now it becomes as, now I can write as, this is solution. Same thing. Now here in vapor state, the pure solvent is there. That means 100% the pure solvent which is in the vapor state. While the completely surface area which is completely occupied by pure solvent. But here the fraction of the surface area which is occupied by the solute molecule, because non-volatile solute, the solute cannot be in the water, in the vapor state, only the solvent, because solvent is volatile. So now I can say that. Now in vapor state, here will be what we can say, the vapor of the solvent which is present, but here completely solvent, which means what I am trying to say that this is solution, this is solvent. We can say that the vapor pressure of solution is always less than that of the vapor pressure of pure solvent if solute is non-volatile. If solute is non-volatile. I'm repeating again. This is vapor pressure of solution, vapor pressure of the solvent. We can say that vapor pressure of solution is less than that of the vapor pressure of pure solvent if solute is non-volatile. Don't forget about it. So vapor pressure of the solution is always less than the vapor pressure of the pure solvent. Fine. So from this we can going to learn what is it called Raoults law. So what the Raoults law says that the Raoults law explains this. Now we have learned that vapor pressure. What is vapor pressure? The vapor pressure is defined as at constant temperature at equilibrium of liquid vapor, the vapor exerted pressure is called vapor pressure. To this, if I am going to add the non-volatile solute, the vapor pressure of the solution is less than that of vapor pressure of the pure solvent. We have learned. Now, what is Raoults law says that when Raoults law, I am going with that here as a case 1 I am going. What is case 1? Solvent can write solute. Solvent is what? Volatile. And solute is what? Non-volatile. Is that case 1. So what he is trying to say, in case 1, solvent and solute, solvent is volatile nature, solute is what? Non-volatile. So now what the definition of Raoults law is telling that the vapor pressure of the solution is directly proportional to mole fraction of the vapor pressure of the solution is directly proportional to x1 is the mole fraction of the solvent. Now I can take it PA is equal to, I can write that A into x1. If I want to draw the graph, look at this. Now I can take the graph. This will be what as XA. Now this will be what as vapor pressure. I'm taking that. Now when I draw the graph, I'm going to get like this. So this is 0 to 1. What is XA? XA is called the mole fraction of the solvent, and Vp is what? The vapor pressure. Now what we can say that video வரலையா? ஏனா என்ன பண்ணணும்? கட் பண்ணிட்டு வரட்டுமா? ஆமா. So very good evening children, we'll start the new topic is liquid solution. So in liquid solution, first we are going to learn what is vapor pressure. Then we can go with what is Raoults law. Then we go with the collinearity properties. If I complete these 3 topics, your liquid solution chapter is over. So first, what is vapor pressure? Vapor pressure we can define as, listen, let us take the liquid. When the liquid, now this is what we can say the surface of the liquid which has a higher kinetic energy. Therefore, their tendency to escape in the vapor form. So initially, what we can say the rate of evaporation is faster. So at the stage is reached. What is the meaning of stage is reached? It means at equilibrium. Equilibrium means what? The rate of evaporation is equal to rate of condensation at constant temperature. Now we can say that the vapor exerted pressure is called vapor pressure. And please keep it in your mind. Higher vapor pressure, the boiling point of the liquid is what? Less. The lower vapor pressure, the boiling point of the liquid is what we can say high. For example, ether you take it. Ether and water. Water has the less vapor pressure, therefore boiling point of water is what? 100 degrees Celsius. Ether, if you take diethyl ether, the boiling point of diethyl ether is what? 35 degrees Celsius, which has the high vapor pressure. So the vapor pressure and boiling point both are is what? Inversely proportional. Fine. Now what I am going to say that, now to this, if I am going to add as a non-volatile solute. So now what will happen? The non-volatile solute, if I am going to add, the fraction of the surface area which is covered by non-volatile solute. In the fraction of area, you have the only less solvent molecule. So that solvent molecule which is in the vapor state, I can say that the vapor pressure of the pure solvent is higher as compared to vapor pressure of pure compared to vapor pressure of solution. We can say that if the solute is non-volatile. Look at this. Now, as I told you that if I am going to add the non-volatile solute to the pure solvent, now I can write it as this circle indicates there is a solute, non-volatile solute. That means the fraction of the surface area which is covered by solute molecule, which does not exist as a vapor. Only the solvent molecule only going to exist as a vapor. So from this we can conclude that the vapor pressure of solution is less than that of vapor pressure of pure solvent if the solute is non-volatile. From this we can define the Raoults law. What Raoults law says that we can take PA is directly proportional to XA. What is XA? Mole fraction of the solvent A. Because here solvent only in the vapor state are not says, therefore the vapor pressure of solution directly proportional to mole fraction of the solvent. So therefore I can write it, I can take it as PA is equal, I am giving as a K is a constant, XE. Now if I draw the graph, look at this, I am going with the graph. Now I can take this is XA 0 to 1 and this will be what PA. PA is called vapor pressure of the solution, and look at this, if I draw that, go straight line. So this is the point which is called, when XA is equal to 1 means what? Only the pure solvent is there, we can call it as a what? P0A. Therefore I can say that XA is equal to 1 means I can say K which is equal to P0A. So from this we can say PA which is equal to P0A into what? XA. So that means the vapor pressure of solution is equal to, we can write that the vapor pressure of pure solvent A into what we can say the mole fraction of solvent A. From this we can say mole fraction is always less than 1. From this we can conclude that the vapor pressure of the solution is always less than that of the vapor pressure of pure solvent if the solute is non-volatile. This is what the Raoults law says that. Now next one, look at this. If I am going to have as ideal solution. Now in this we have learned in that Raoults law, the case one is what? When the solute and solvent is volatile, solute is non-volatile. Suppose if both the components A and B both are is what? Volatile nature, how we are going to find out the total vapor pressure of solution? How we are going to find out it? Look at here. Now I can take it that. I can take it as this. So let us take this component A and going with this component B. That means both A and B are volatile nature. Now how to find out what is its ideal solution? That means what is the total pressure? The sum of partial pressure of A plus partial pressure of B. Therefore I can write that PT is equal to, I can take it as PA plus PB. As per the Raoults law, we can write that PA is equal to P0A XA, and write that P0B is equal to P0B into what is that? XB. Now this is XA is what? The mole fraction of solvent A in solution. XB is what? Mole fraction of solvent B in what we can say as a component B in solution. XA, XB, component A and component B, mole fraction in solution. And XB is what? The mole fraction of component B in solution. Now I can take it. PT is nothing but is total pressure. Anyway, it's the ideal solution. Therefore, we can take it as PA plus I can write PB. What is I can write PA? I can take it as P0A XA. I can take it as P0B XB. Now we can take it as P0A XA plus, we can write XA plus XB is equal to 1. I can write that XB is equal to 1 minus XA. Now I can write it XB is nothing but is what? P0B 1 minus XA. I can take it as P naught A XA plus P naught B minus P naught B XA is equal to. Now I can write it as PT is equal to, and write it as PT is equal to PT, which is equal to, I can write it as P naught B plus P naught A minus P naught B as XA. This is what you are going to get. If you know P naught B, if you know the P naught A and P naught B of what we can say. What is P naught A, P naught B? Vapor pressure of pure component A and component B. If you know the mole fraction of component A, you can able to find out the total pressure of the component A, component B solution. That means we can able to find out total vapor pressure of the solution. Now what is the graph says that? Look at this. Now I can take it as per if I am going with that. That's all. Now I can take it 0 to 1 for XA, 0 to 1 for is what? XB. That's all. So this will be nothing but P naught B, nothing but is what? P naught A. So always the total pressure is better in this. Therefore I can say that P is equal to PA plus PB. This is what the Raoults law for what we can say the ideal solution. That means any solution obeys Raoults law. The solution is called ideal solution. The ideal solution means what? Whenever they are going to intermix, the heat never released or heat never what we can say absorbed. But the entropy of system is what? Positive. Don't forget about it. We can say that for the ideal solution, delta H mixing is what? 0. And delta V mixing is what we can say as a 0. Don't forget about it. Please keep it in mind. For ideal solution, for any ideal solution, we can say delta HV mixing is what? 0. Why? Heat energy never released, heat energy never absorbed. Why is that? Because ideal solution means what? There is no interactive force between what we can say AA or AB. Or suppose we are taking component A, component B. That means A and BB, if I'm going to mix it, we can say that the interaction of AA or interaction of BB, which is equal to what we can say interaction of AB. So therefore, such solutions are called what we can say ideal solution. If I'm saying ideal solution means what? They obeys Raoults law. And one more thing, we can able to find out, if I know this, I can just now I can write it. Look at this. Now I want to find out at equilibrium. Anyway, they are in the vapor phase. If I want to find out what is the mole fraction of A and mole fraction of B in the vapor phase, how I am going to find out it? Look at here. Now I can use the Dalton law of partial pressure. What Dalton law says that I can take it. PA is equal to this is XAV. This is mole fraction of A in the vapor phase into what is that? PT. Now I can take it as XAV is equal to I can take it PA by PT. So what is PA? I can take it P naught A XA by what is PT? I can take it P naught A XA plus I can take it P naught B XB. So we know that XAV plus XBV is equal to 1. So once we know the XAV, we can able to find out what is XBV. What is XAV? Mole fraction of A in vapor phase. XBV is what? Mole fraction of B in the vapor phase. That's all. So can we discuss one problem based on this? You can have the idea. Look at the question. So question what they are asking is, listen. Now the question what they are asking this, note it down. The liquid A and B form ideal solution. Right? Liquid A and B form ideal solution. Liquid A and B form ideal solution at the entire composition. At the entire composition at 350 Kelvin. At 350 Kelvin. P naught A is equal to, I can write that P naught B is equal to, I can say that the P naught A is equal to 7 into 10 power 3 Pascal. This will be P naught B, the value could be 12 into 10 power 3 Pascal. Now, what the question? The question what they are asking, look at this. The liquid A and B form ideal solution at 350 Kelvin with the entire range of composition. The P naught A 7 in 10 power 3 Pascal, P naught B 12 in 10 power 3 Pascal. The question is the composition of vapor. The composition of vapor is in equilibrium with solution containing 40% mole of air. This is what the question is given. 40% of, I can say 40 mole percent of A at this temperature. The question what they are asking, find out the composition of vapor is in equilibrium with the solution containing 40 mole percent of A at this temperature. So how to solve this? So they are given is what? P naught A is given, P naught B is given. First we want to find out what is the total vapor pressure of solution. We know the formula. What is the formula? I can write it. Pt, which is equal to, I can write that Pa plus Pb. So what is Pa? As per the Raoults law, we can write that P naught A Xa plus we can take it P naught B Xb. Now look at this. They are given 40 mole percent. 40 mole percent means what? Xa is equal to 0.4. Xb is equal to what? 0.6. Now P naught A, what is given? We can write it as 7 into 10 power 3 into 0.4 plus 12 into 10 power 3 into 0.6 is nothing but Pt. Now look at that. Next I want to find out what I want to find out as a vapor phase of A and B. Just now I have told, as per the Dalton law of partial pressure, I can take it as XAB, it is equal to, I can take it as PA by PT. What is PA? We know the value of PA. PA is nothing but P naught A XA by what is PT? This is the value. That means we can take it 7 into 0.4, 2.8 into 10 power 3 plus 12 into 6 is what? 7.2. 7.2 into 10 power 3. What is P naught A XA? We know that as, I can take it as XAB is equal to P naught A is what? 7 into 10 power 3. What is the mole fraction? It is what? 0.4 by. So 7.2 plus 2.8 is 10. I can write 10 into 10 power 3. Cancel it off. Now what I am going to have is, so 2.8 by 10. Therefore that XAV, which is equal to what? 0.28 is XAV. What about XBV? We are going to get is what? 0.7. That's all is the answer. This is what you may expect in the JEE mains of point of view. Repeating the question, liquid A and B form ideal solution at 350 Kelvin entire range, and P naught A and P naught B is given. Find the composition of vapor is in the equilibrium with the solution containing 40 mole percent of A at this temperature. So what is the, I want to find out the vapor phase of A. We know that XAV is equal to PA by PT. What is PT? We can say that PA plus PT as per Raoults law. P naught A XA, P naught B XP. What is XA is given 40 mole percent, that means 0.4. And what about XB in the solution? 0.6. Simplify, you may get the answer. Final answer is what? XAV is equal to 0.28 and the XPV is what? 0.72. These type of questions you may expect for JEE mains. That's all. Now come to the point. And this is about over. Now, deviation of Raoults law. What is deviation Raoults law? Because if I want to say that, obviously, ideal solution generally never exist. What solution exists? Only real solution. In that, there are two type of deviation. One is called positive deviation. Another one is called negative deviation. What is positive deviation? That means when I'm taking, look at this. I'm taking an example for positive deviation. Positive deviation. I'm taking example of CH3, CH2OH plus I'm taking is what? Hexane, ethanol plus hexane. Now I can say this is A. I can say this is what? When I'm going to mix this, what I'm going to get as AE. Now we can say that ethanol has is what? Hydrogen bonding. Ethanol has is what? Hydrogen bonding. When the hexane, if I am going to mix it, what is going to happen? Hydrogen bonding is going to be break. Therefore, the AB is formed. Therefore, the AB interaction is weaker than AA or BB interaction. In such cases, so what we are expecting the vapor pressure is higher than that of what we can say that ideal one. So that means what is the graph we are going to get it for the positive deviation? Look at this. This is what, as just now we have discussed, this is for that Raoults law. That means ideal solution. So now I can say this is for the Raoults law. Now, what is positive deviation? We are going to, what we can say, expect higher than the top of the ideal solution, which means that this is what we can say that A, this is PB, I can say that XB, what XA. Why? Because of ethanol has the hydrogen bonding. After mixing, the hydrogen bonding is going to break. Because of that, the volume of mixing is going to increase. Alright, to break that, the enthalpy of mixing, what is going to happen? The enthalpy of mixing is becomes what? Positive. Why? You are going to break the bond. Are able to follow what I am trying? This is what we can say. This is the vapor pressure is higher as compared to what we can say ideal one. That means when you are going to any one of the form, what we can say will be easier to what we can say escape. Escaping energy is more as compared to what we can say ideal one. That is called positive deviation. Ethanol, we can say what are all example of positive deviation? Ethanol plus water is the positive deviation. Acetone plus CS2 is the positive deviation. Why acetone plus CS2 is the example of positive deviation? Because acetone has dipole-dipole interaction. When the carbon disulfide is going to mix it, that the dipole-dipole interaction is going to break. Therefore, after mixing, the solution has the higher vapor pressure than the expected one. Therefore, they are called positive deviation. Fine. And what is about the negative deviation? Look at this. I'm going in the negative deviation. I'll take the example. Listen. I'm taking negative deviation. Negative deviation. Let us take the example of negative deviation. I'll take as CH3, C double bond O, CH3 plus CHCl. Let us take the example. Acetone and chloroform, I am going to mix it. So here what we are expecting, the vapor pressure is less than that of what we can say the expected one. Why? What is the reason? Because when I am going to mix this, C double bond O, here is what CH3, here is also CH3. Now C bond H is Cl, this is Cl, this is what Cl. Acetone and chloroform I am taking. Now what is happening? This is as delta minus, this is what delta plus, there is interaction takes place. Look at this, because of the more interaction between the AB, therefore they cannot escape it easily. Therefore, the solution which will have that less vapor pressure than expected one. That means the AB interaction is stronger than AA or BB interaction. So what is the graph we are going to get it? Look at that, the graph which we are going to get it as. I can draw in this. This is what the expected one. This is what expected one. I can say this is as EA. This is what as AB. I can say this is XA and what XB. This is what the expected one. But here what interaction is more. Therefore, solution will have the less vapor pressure than the expected. This means what I can say. This is the less. So because of this, obviously this also will have that less. So this also will have less. So that means that Raoults law, the solution which is deviating from Raoults law. One is called positive deviation, another one is called negative deviation. What about the positive deviation? That means AA interaction, BB interaction are stronger than AB interaction. That means, in other words, we can say AB interactions are weaker than AA or BB interaction. What about the negative deviation? Negative deviation means what? AB interactions are stronger than AA or BB interaction. Therefore, they have the less vapor pressure than expected one. So that is called, they are going to form as a maximum boiling azeotropes. For positive deviation, they are going to form minimum boiling azeotrope because they can tendency to escape easily as compared to the pure state. Right? And so this is what we can say the Raoults law. Now we will go with the colligative properties. So what the colligative property says that, listen, very important here. Now, when, as I told you that, there are 4 important properties. What is that? I'll write one by one, explain you. One will be relative lowering of vapor pressure of solvent. And 2 will be, I am going with elevation of boiling point. Boiling point of solvent. And 3 will be, I can go with the depression of freezing point. And last will be, I can go with the osmotic pressure. This is what I mean. Look at this. Relative lowering of vapor pressure of solvent, elevation of boiling point of solvent, depression freezing point of solvent, and osmotic pressure of solution. These 4 properties are called colligative properties. Why? The sum of the properties which are connected to the, what we can say, decrease in vapor pressure of the solution. Am I right? What is the properties? These 4. That means these properties are depends on the number of particles present in the solution. They are not depends on, what we can say, the nature of the solute. And very important condition, the colligative property is only applicable for solution must be dilute solution, and solute should not undergo any dissociation or association. Then only the what I am going to derive the equations are holds good. If they undergone dissociation or association, we have to introduce the factor is called Vanta factor. We have to introduce. Now come to the one. Listen. Now, first I am going with the relative lowering of vapor pressure, as we know from the Raoults law. So what we have learned, when the non-volatile solute is added to the pure solvent, vapor pressure of solvent is going to what? Decreases, or we can vapor pressure of solution is what? Decreases. Now, as per the Raoults law, we can write that PA, which is equal to, I can write that P naught A X1. Right? Or I can take it as P. Very simple. P naught X1. Now, when I add non-volatile solute, delta P, which is equal, I can write that P naught minus this one P. What is P here? I can take it as P naught minus P naught X1. Delta P is what? So therefore, I can take it as P naught 1 minus X1. P naught minus P by. That's all. So this is P naught minus P by P naught is called relative lowering of vapor pressure. What is X2? Mole fraction of the solute. This can be simplified. What is mole fraction? Again, write it as N2 by N1 plus N2. Here what? The solution is what? It's the dilute solution. Therefore, the particle of N2 will be very, very less. We can neglect that. Therefore, we can write it as N2 by N1. What is N2? Weight by molecular weight of the solute. What is N1? Weight by molecular weight of the solvent. Therefore, I can write it as P0 minus P by P0 is equal to N2 is what? W2 by M2. What is N1? W1 by M1 or not? This is what? I can write that M1 by W1. This term is called what as a molarity. Why? We can say that this is nothing but weight per molecular weight. This weight per molecular weight nothing but number of moles of solute present in the weight of the solvent in 1 kg mean is called molarity. Therefore, I can write that P0 minus P by P0 is equal to M. That means I go with that M into M1. This is what. And one more thing, using this equation, we can able to find out the molecular mass of the solute. If we know the P0, if we know the vapor pressure of the solution, if we know the weight of the solvent, if we know the molecular mass of the solvent, if we know the weight of the solute, we can able to find out the molar mass of the solute. Unknown solute, we can able to find out it. This is about what we can say as a relative lowering of vapor pressure. First, I will discuss all the theory part, then we will discuss finally problem. Now, next one. Come to the next will be what? As here, I am going with elevation of boiling point. So first we should know. So what is the definition of boiling point? The boiling point is defined as, for particular liquid, the vapor pressure is equal to what? Atmospheric pressure. Vapor pressure is equal to what? Atmospheric pressure. Now, if I go with that, listen. Now I am going with as this is temperature. This I am going with what? Vapor pressure. Now this is nothing but as you can go with that 1 atmosphere. What? 1 atmosphere I am getting that. This is solvent. I am going, this is what? Solution. Now this is solvent, this is solution. Now what definition of the vapor pressure of the solvent? We can say that vapor pressure is equal to atmospheric pressure. That time solution start boils. So this is called, I can keep in as. Now in the case of solution, look at this. Solution means what? When you are going to add the non-volatile solute, vapor pressure of the solvent decreases. In order to solution must be boiled, you must increase temperature. So therefore we can say that the boiling point of solution is always greater than the boiling point of the solvent if the solute is what? Non-volatile nature. So now I'm going to add this. This is the boiling point of the solvent. This is nothing but I'm keeping Ts. This is the boiling point of solution. This is boiling point of solvent. This difference is called what we can say as delta TB. Delta TB is called what? Elevation in boiling point. Therefore, delta TB is equal to, we can write that Ts minus what is that? What is Ts? That means boiling point of the solution minus the boiling point of pure solvent. So why is that boiling point of solution is always higher? Why? When the non-volatile solute is added to the pure solvent, vapor pressure decreases. In order to solution must be boiled, so you have to, what we can say, vapor pressure is equal to atmospheric pressure, you have to increase the temperature. So very simple, we can say that we know that water boils at 100 degrees Celsius. Suppose if it is 1 molar sucrose solution, boiling point is always greater than that of what we can say 100 degrees Celsius. Why? 1 molar sucrose solution means what we can say, which has the solute is present as a sucrose. Therefore, vapor pressure of solution of 1 molar solution of sucrose is less than that of the pure water. If vapor pressure of the 1 molar sucrose solution is less than that of the pure water molecule. Therefore, the boiling point of 1 molar sucrose solution is higher than that of pure solvent of water. Now, from this, I want to derive that. We know that. Therefore, delta TB is directly proportional to what we can say the change in the vapor pressure. I can write as, listen to me. Delta TB is directly proportional to what? Delta P. Just now we have learned what is delta P. We have learned as, we can go with that as P naught into X2. So what is X2? X2, you know that. That's a mole fraction of the solute. Anyway, this must be dilute solution. We can write N2 by N1. And that is what N2 by N1. So N2 by N1 just now written as delta PV is nothing but P naught W2 by M2 into M1 by W1. Obviously is what P naught and M1 is always constant for the pure solvent. So therefore W2 by M2 by W1 is called molality. Therefore I can write it as delta PV is nothing but is M. What is M is nothing but molality. To remove this proportionality term, I am introducing what I can write as delta PV is equal to KB into M. What is KB is nothing but, the KB is nothing but the molar elevation constant is depends on nature of the solvent. Therefore we can write KB is nothing but, we can write R TB square into M1 by delta HB. If you multiply 1000 means we can say as joule will come that. Am I right or not? See, why into multiply 1000? To what we can say unit must be more important here. Am I right? From this KB unit is what? This is molar. So KB, this is delta TB Kelvin. We can say kg per mole Kelvin. Kg per mole Kelvin is the unit of what we can say as KB. So same thing has to come R TB squared into M1 by delta HB. Therefore, the KB depends on the nature of the solvent. What delta HB is what? We can say that enthalpy of vaporization. Enthalpy of vaporization. R must be used 8.314. And here the M1, if you are going to use molecular mass in terms of what we can say as kg, it's better. If you use kg, 1000 is not what we can say required here. That's all. That's all. This is what the logic. So this is over. So what is boiling point definition? We can say that the vapor pressure is equal to atmospheric pressure. It's called boiling point. Right, for solution, by adding non-volatile solute, the boiling point is increases while vapor pressure decreases. Now come to the point, same logic. Now we are going with that as, now next one, freezing point. Depressurant freezing point. Depressurant freezing point means what? Same logic. What is the definition of freezing point? Look at this. When we are going with that. Now I am taking this is vapor pressure. This I can say as temperature. This I can say this is solvent. This as a solid phase. This is what as liquid phase. Now, what is the definition of the freezing point? The freezing point defined as the solvent of what we can say the solid and liquid which has the same vapor pressure, which is defined as the freezing point. I can keep it as here. This is T. I am keeping as TF naught. Now, if I am going to add that non-volatile solute, obviously what vapor pressure of this is, I can write it just to understand. I don't explain it. This is TF. This difference is called delta TF is equal to TF naught minus is what? TF. So what is Y? Look at this. Now I want to say this is solution. See, we know that when the non-volatile solute is added, vapor pressure of the solvent, the vapor pressure of solution is what? Decreases. The solution will freeze when vapor pressure of solution is equal to what we can say vapor pressure of the solid. We know that as per the Raoults law, by adding the non-volatile solute, vapor pressure is decreases. So in order to what we can say the freeze, the temperature must be is what we can decreases. Why? Vapor pressure is less. When vapor pressure is less, definite temperature will decreases. When temperature decreases means obviously look at this. Two solution must be freeze. Vapor pressure of solution must be equal to the vapor pressure of the solid. When vapor pressure of solution must be vapor pressure of solid means when you are going to add the non-volatile solute, vapor pressure is decreases or not, say yes or no. In order to equal that, the temperature must be lower. Therefore, what we can say, the freezing point of the solution is decreases. That means what we can say always. This is the freezing point of the pure solvent. This is the freezing point of the solution. So from this same logic we can use it. What we can write delta EF is equal to KF M. So what is KF here? We can say the present freezing point constant. M is what? Molality. And TF, you know that it's a difference in the TF naught minus TF. That's all. Over. And last will be is what? And even one more thing I want to say that. What is that? I can take it as KF is equal to R. That's all. This is delta H fusion. This is molar mass of the solvent. This is freezing point of the solvent. R value 8.314. So the KF and KB is depends on the nature of the solvent. And last will be is what? Osmotic pressure. Osmotic pressure. What is osmotic pressure? Before you should know what is SPM. SPM is called semi-permeable membrane, which allows only what? Solvent. It allows only solvent. Let us take one simple example to understand. Look at this. Now, I am keeping here the solution is there, and we can take it as this is called SPM. This is I am keeping as SPM. Just to understand that this. Now here I can say that this is what solvent. Here is what solution. Now what is SPM related? General, what is the role of SPM? Which allows only what we can say solvent particle. Obviously what the solvent particle is going to move through semi-permeable membrane. Obviously what the solution side, what we can say that the liquid level becomes what? Increases because of the entering into solvent molecule through what we can say SPM. So this process is called what we can say osmosis. This process is called what we can say osmosis. What is osmosis? In SPM, the solvent molecule is going to move through the SPM. Because of that, what we can say the solution side is going to increase the state. Now, what is the definition of osmotic pressure? To stop the what we can say process of osmosis, add the extra pressure on the solution side to stop the flow of solvent molecule through SPM. That pressure is called what? Osmotic pressure. What is osmotic pressure? Simply, if I want to say that, very simple. What? At equilibrium, what we can say, the flow of solvent, that means the osmosis process should be stopped. Therefore, we are going to add the excess of pressure on the solution side. That pressure is called osmotic pressure. That's all. So now we can write that pi, which is equal, we can write as CRP. What is pi is called osmotic pressure. C is nothing but the concentration of solution in terms of molarity. R is what? 0.08. Temperature is what? At particular temperature. And what is isotonic solution? Isotonic solution means the two solutions have same osmotic pressure. And we are going to keep it in that they never, what we can say, the flow of solvent from solution to what we can say other solution. No osmosis occurs. That is called isotonic solution. Isotonic solution means what? They have same osmotic pressure. So now I gave the 4 equation. What is the 4 equation? Listen to me. Now I can say that one will be P naught minus P by P naught is equal to X2 delta TB is equal to KB into M. I can write that delta TF is equal to KF into M and phi is equal to CRT. Look at this. These 4 equation is only applicable for non-electrolyte, which means that what? Solute should not undergone any dissociation or association. Suppose if the solute undergone dissociation or association, you must introduce the factor is called Van 't Hoff factor. What is Van 't Hoff factor? I must be used. That means for this I can go with that as non-electrolyte. For electrolyte, we can use P naught minus P by P naught is equal to I into X2. Delta PV is equal to I into KV into M. Now delta TF is equal to I into KF into M. And phi is equal to I CF. This is for electrolyte. Why? Electrolytes undergone dissociation as well as association. When dissociation takes place, I is always greater than 1. Then how they will find out for the dissociation? Very simple. We take it as alpha is equal to I minus 1 by N minus 1. This is for dissociation. This is for dissociation. Now we can write that alpha is equal to 1 minus I by 1 minus 1 by N. This is for association. Association is, we can say that I is less than 1. For dissociation, I is what? Greater than 1. Here N is nothing but, for dissociation, N is nothing but number of particles present inside the solution. We'll discuss the question. So this is what we can say that solution. Now we will discuss some good questions which gives them more and more confidence. Starting with, look at that question. Which of the following solution? Which of the following solution have highest boiling point? Okay, assume that all are equal molar, what we can say, concentration. All must be equal molar. Now, I can say A. I'll go 0.1 of Fe H2O 4 times Cl. Option B, 0.1 can go with the molar. We can say that Fe H2O 3 times Cl3. Option C, 0.1 molar Fe H2O 6 times Cl3. Option D, 0.1 molar Fe H2O 5 times Cl. Sir, they have given us a complex. They are asking which of the following solution have highest boiling point. So highest boiling point, anyway we know that Kb it's anyway water only. Kb will be remain same and molality also same. Which it is a delta Tb, that means Van 't Hoff factor, because here all will be is one electrolyte because all are complex. Then how to find out? We know that complex, whatever the inner sphere, they never ionize. Whatever the outer only they are going to ionize or not ionize. That means which is going to produce more number of ions. Which is going to produce the more number of ions, we can say that they have that, what we can say that highest boiling point. When highest boiling point, that will have the lowest what we can say vapor pressure. Don't forget about it. Look at this. Now I will take one by one option here. How dissociate? Look at this. Now I write the formula. We can say that delta TV is equal to I into KV into M. Anyway, this must be constant. Therefore, we can say that delta TV is directly proportional to I. If the I value higher, delta TB is higher, not lesser. Now look at this. Now I'm taking definitely option is what? C is the correct option. Why C is the correct option? Look at this. When it's dissociate as Fe H2O 6 times 3 plus 3 Cl minus. You have 3 Cl minus ion plus this 1 ion. Totally what we can say in this case, I which is equal to 4. Now here we have 2 Cl minus ion, this is 1 ion, I can say I which is equal to 3. And here must be I is equal to 1, here I is equal to 2. Therefore, this will have what we can say the I value under factor is 4. Therefore, we can say that this solution have the highest boiling point. Option C is right. Now the one more question, look at this. Now the next question. The which of the following solution? Which of the following solution have highest freezing point? So the following has highest freezing point. Right, answer. Now options are option A, Cr H2O 6 times Cl3, Cr H2O 4 times Cl2 Cl. Option C, Cr H2O 3 times Cl3. Now option B, Cr H2O 5 times Cl Cl. Now all will have the same concentration of 0.1 mole. So I have given a Cr H2O 6 times Cl3. So which of the following has highest freezing point? So generally highest freezing point means what? Please keep it in your mind. I must be 1. Because we know that, look at this, delta Tf is equal to I into Kf into M. That means delta Tf is greater than I, which means that whenever the I is more, the freezing point is less. They are asking highest, right? Highest freezing point, right? And which means that what? When I value is less, they have the highest freezing point. When I value is more, they have the lowest freezing point. They will faster. The solution will freeze very fast if I value is high. But they are asking what highest freezing point. Look at this. We know that this is Cl3, 3 Cl minus. Therefore, here will be I, which is equal to 4. Here I, which is equal to 2. Here I is what? 1. Here I is equal to what you can say as 3. Now what we can say which will have the highest freezing point of solution. And this is what you may expect what we can say IIT. Now the next question. The next question what they are asking. The same thing. Now I want to clean this. The question what they are asking. The formula which is given as, the formula is given CrCl3 dot CrCl3 dot X NH3 is given. CrCl3 dot X NH3. The elevation in boiling point. Elevation in boiling point. Elevation in boiling point. 1 molar solution. 1 molar solution is triple of 1 molar solution of urea, find the value of X. Assume that is undergone 100% dissociation. So how to find out what is the value of X? The question is, this is the complex is given CrCl-hexaNH3. Elevation and boiling point of 1 molar solution is triple of 1 molar solution of urea. Find the value of X. So now we know that obviously they are given. Assume that it is 100% dissociation. Is what is given. Now I am writing that delta PV by delta PV of urea is given as I into Kv into N by, anyway urea is what, it's a non-electrolyte, cancelled off. Now this delta PV of this will be 3 times as delta PV of urea, therefore we can say that I is equal to 3. When I equal to 3 means what must be the X value? Look at this. Now we can write it as Cr NH3 5 times Cl Cl2. Now I can say that Cr NH3 5 times Cl plus 2Cl minus. Look at this. Now what we can say that here 2 ions, here 1 ion, therefore I must be 1. So what is the value of X must be? X is equal to 5. So you may expect these type of questions in the JEE mains. Now next question. The next question come to the point. Now please copy this. I want to give you one more question. One more question is, question is, write down. The question is, yeah. So very important question. This is somewhat tough question also. The question says that 0.004 molar of Na2SO4. It's a nice question. This is. We can say that. I want to clean this. Listen. The question is I can say that 0.004 molar solution of Na2SO4 is isotonic with 0.004 molar solution of Na2SO4 is isotonic with 10 power minus 2 molar of glucose solution. 10 power minus 2 molar of glucose solution. Find the degree of find the percentage dissociation of Na2SO4. Find percentage dissociation of Na2SO4. So now, what is the meaning of here isotonic? The solution which have the same osmotic pressure. Please understand, Na2SO4 is electrolyte and glucose is what is a non-electrolyte. Therefore, we can write pi is equal to, we can write ICRT and we can write pi is equal to CRT. We can write CRT for glucose, ICRT for what? Na2SO4. Both will be isotonic. That means I can write that ICRT is equal to, I can write as a CRT. Therefore, this RT cancelled out. I can write that 4 into 10 power minus 3. This must be is what? 10 power minus 2. Now I can write it I, which is equal to 10 power minus 2 by 4 into 10 power minus 3. Therefore, 10 by 4. 10 by 4 means what is here? I must be 2.5. I is what? 2.5. What they are asking alpha. Anyway, Na2SO4 undergone dissociation. We can go with that. Alpha, which is equal to I minus 1 divided by N minus 1. So I told you what is N is nothing but number of ions present in the solution undergone dissociation. How Na2SO4? Na2SO4, if you can write that 2 Na plus SO4 2 minus, therefore 2 plus 1, I have the 3 ions. Therefore I is what? 2.5 minus 1 divided by N is what? 3 ions. 3 minus 1, we can write that 1.5 by 2 is nothing but is what? 0.75. Answer is what? So this is what you may expect the JEE mains point of view. And next one, the question they are given is, look at that. Now they are given the next question is, find out, listen, find out, they are given K of the acid of HX. Find the K of the acid of HX, they said, is 0.2 molal, 0.2 molal of solution, 0.2 molal of solution, 0.2 molal solution, 20% ionized, 20% ionized, 20% ionized. Calculate Ka of the acid and delta. Calculate the Ka of the acid and delta Tf. So now we can say that delta Tf is equal to, one more point I want to say that, assume that molality is equal to molarity. Therefore delta Tf is equal to I into Kf into Tm. Therefore I want to find out it. They gave 20% is ionized. We can write that alpha is equal to T minus 1 by N minus 1. Alpha is equal to I minus 1 divided by N minus 1. So what is that? I want to find out I. Alpha is what? 20%. HX is what? Monobasic acid. Therefore we can write that I is equal to 1.5. Therefore delta Tf is equal to 1.2 into, we can say that anyway it is in water. Kf is what? 1.86. M is what? Now next will be what you want to find out as Ka of the acid. Ka is equal to C alpha square. So I told you to assume that molarity is equal to molarity. Therefore this will be what? C is what as 0.2 and alpha squared is what? 0.2 whole square. Therefore we can say that 8 into 10 power minus 3 is the answer. This is what in the examination point of view you may expect that. So, right, next question. So what is the, they are telling that find out want half factor. Find out one half factor of K4, Fe, C and 6 if it is ionized 60%. Ionized is what? 60%. That means what you have to do, look at this. Say K4 FeCN6. We can take it as 4K plus FeCN6 as 4 minus. CN6 is what? 4 minus. So number of ions is what? 4 plus 1 is equal to 5 is nothing but is what? N. So we can say that alpha is equal to I minus 1 by N minus 1. So now they are asking is what? They are find out Vanta factor. I want to find out it. What is the N must be here 5. How much dissociated? Only 60%. I can write that 0.6 is equal to I minus 1 by how many ions are there? 5. 5 minus 1 is what? 4 I can say. So 2.4. Therefore I which is equal to 2.4 plus 1. Are they able to follow? Listen. Only one more question. Calculate the osmotic pressure of acetic acid. That is. Listen, calculate osmotic pressure of pressure of 0.1 molar of acetic acid having pH is equal to 2 at 27 degrees Celsius. This is what they are asking. Calculate the osmotic pressure of 0.1 molar acetic acid having pH equal to 2 at 27 degrees Celsius. Right? So how to find out? Because acetic acid is a weak monobasic acid. When weak monobasic acid means what? We can go with that. Pi is equal to ICRT. Now what I want to find out is, I want to find out I. What they have given us, they have given us pH. And pH means what? I can say that concentration of H plus ion is what? 10 power minus 2. From this, how I am going to find out I? That's a question mark. Right? Not now. H plus 10 power minus 2. We can write as per the Oswald dilution law, which we discussed in the last class. We can write that C alpha, which is equal to 10 power minus 2. Right? Now, what is alpha? Alpha is nothing but 10 power minus 2 by what is C is given 0.1. Right? So therefore alpha is equal to 0.1. Anyway, acetic acid is going to dissociate or not? Yes or no? Therefore I can write alpha is equal to I minus 1 by N minus 1. Therefore acetic acid is going to produce 2 ions in solution. What is alpha is what? 0.1. 0.1 is equal to I minus 1 by 1 because N is nothing but 2. Therefore, what is the value of I? I which is equal to 1.1. Now, I want to find out that I is equal to, I is what? I is 1.1, concentration is what? 0.1. R value very important as 0.082 into 300. So now we can write as this is nothing but 0.11 into 0.082. This is what the answer. These type of questions you may expect in the JEE. Next question. exam, they may give like this. How they will give you? Look at this. I'm having as, look at this. Here. Now, I'll write as FeOH thrice as a saturated solution. Saturated solution. We can say that the solution having pH is equal to 12. Solution having pH is equal to 12. Calculate vapor pressure of solution. They are asking you to find out vapor pressure of solution. We can say that vapor pressure of pure water, take it 25 mm of mercury at 25 degrees. So this time taking one hypothetical question. Listen to me. They are given saturated solution of ferric hydroxide having pH equal to 12 and calculate the vapor pressure of the solution provided vapor pressure of the pure water is 25 mm of mercury at 25 degrees Celsius. How to find out? That's a question mark. Here assume that molarity is equal to molality. Assume that this is what is. So how to solve this? Now I want to first find out the concentration is required because I gave pH equal to 12. Right? So how to find out this? Right? Now come to now. So I want to find out as P0 minus P by P0 is equal to I into M. Is it? I into M into what we can say. What I want to use that M1 is what anyway the molecular mass of the water. How to find out M? Look at this. We can go with that. Fe OH thrice. You have that Fe 3 plus we can say as 3 OH minus 1. They gave us, we know that they gave us what? pH. You can say that pH is equal to 12 is given. Then what about pOH? pOH is equal to 2. Then what about the OH minus 1 concentration? It's nothing but as 10 power minus 2. Therefore, 3, we can say that 3s is equal to 10 power minus 2. This is what? 10 power minus 2 by 3. This is what that the molality, or you can say molarity is equal to molality. This is what M. And look at this. Now you have the anyway, when the saturated solution, we are assuming that this must be 100% ionized. Therefore, Fe3 plus 3 OH minus I must be is what? 4. Now I can use E0 minus E by E0 is equal to, you can say I is what? 4 into M is what? 10 power minus 2 by 3 into M1 is what? Molecular mass of the solvent. Even is water. You can take 18 into 10 power minus 2. Now substitute that. What is P0? Nothing but as 25. You take it. 25 minus P by 25 is nothing but 4 into 10 power minus 5 into 18 by 3. 3 means we can take it as what? 6. By 6 4s are 24. Now we can take it as now from this 25 minus E is nothing but 24 into 25 10 power. Now we can take it 25 minus Therefore, we can, okay, no problem. 24 into what is that? 25. 10 power minus 5 is equal. This is what the answer of the question. This is how you have to prepare for the next question. Now, the question is, which of the following, very important, which of the following solution have highest osmotic pressure? I'm going back. Which of the following solution have highest osmotic pressure? I'm going option A. Listen carefully. 0.1 normal of urea. Option B. 0.12 normal of CaCl2. Option C. 0.15 normal of NaCl. Option D will be 0.25 normal of Na3PO4. Assume that all will be ionized 100%. Look at this, I'm asking which of the following solution have the highest osmotic pressure. So here very interesting. Anyway, at same temperature, I'm going with that. No problem. At same temperature. So how we are going to answer the question? How we are going to answer the question? Logic is what? Pi is equal to CRT. Now in these three cases, C is what? As a molarity. But here what they are given is what? Normality which is given. Now I am going with that. In this case, pi is equal to CRT. Anyway, why? Because in this case normality is equal to molarity. Therefore RT is constant. Therefore as 0.1 RT. Now in this case, they are given normality. I want to find out molarity. How to find out normality? Look at this. Normality is equal to molarity into n factor. What is n factor? Here the total, the charge we can say that. Totally nullified charge we can say. See, Ca2 plus 2Cl. Therefore the n factor of CaCl2 is 2. Therefore what I can say as m is nothing but 0.12 by 2. That means I can say it will be, therefore I can write pi is equal to I into CRT. I can write that I is what? CaCl2, 3 ions. 3 into 0.12 into 2 is equal to RT. Therefore we can say this is nothing but as 0.6. So for 3 into 0.6, 1.8 RT. Nice question. Now come to the point of NaCl. 0.15 NaCl. Now same thing I am taking. What is M? M in the case of NaCl is what? Plus and minus. Therefore the n factor is what? 1. Therefore M is equal to 0.15 by 1. Therefore phi is equal to, you say that I CRT. In this case I use what? 2 because NaCl produce 2 ions. Na plus Cl minus ion 2 into, what about that? M is nothing but 0.15 into RT. Therefore can we say that 2 into 0.15 we can say as 0.3 RT. Sorry, this will be 30. It's 0.15. Can say that 0.3 RT. Fine. next will be as Na3PO4. We can say that pi which is equal to ICRT. I think this will be as 0.06. I made a mistake. Therefore, this could be as a what as 0.18. Right. Therefore, 0.12 by 2 is what 0.06. Therefore, your varying is what 0.3 RT. The calculation mistake. Write down very important. 0.18 RT. This will be what I is equal to CRT. Therefore, Na3PO4 we can write it as M 0.25 by 3. I is what 4. We can take it as 4 into 0.25 by 3 into RT. 4 1 by 3. 1 by 3 means 0.33 RT. Look at this, it will have the highest value. Look at the questions. A lot of questions. Look at this. These type of questions you may definitely expect for the JEE mains. So what they are asking, which are the following solution have the what is the highest osmotic pressure? So that means here the concentration of different normality are given. What is normality? Molarity into n factor. How to find the n factor of the charge? Very simple. Take the ionization of what we can say. Once dissolve it, take any cations. Charge of cations into number of ions. Take the CaCl2. So in that cation you take it Ca2 plus, only one Ca2 plus ion, therefore n factor is 2. That's all. This is what answer is what? Is that? Now, the next question I want to go. Another very simple question. Which of the following solution has lowest freezing point? Which of the following have lowest freezing point? Option A will be. I'm going with all must be okay. 0.1 molar aluminum chloride. Assume that molarity is equal to molality. Option B, 0.1 molar as potassium sulfate, right? Potassium sulfate. We can go with that option. C will be 0.1 molar calcium sulfate. Option D will be 0.1 molar calcium sulfate, potassium sulfate, and here magnesium sulfate. So how to answer? Very simple. All are electrolytes. Here is what? All are electrolytes. Here 0.1 molar aluminum chloride. I must be 2 because it is nothing but now it's like this. NH3 plus and Cl minus. Calcium sulfate CaSO4. I must be generally sparingly soluble salt. Assume that it is ionized. Magnesium sulfate, we can say I is equal to, but potassium sulfate, KTSO4. We can say that 2K plus this one 4. What we can say, I must be is what? 3. Therefore, answer is what? Is the answer. So these type of questions you may expect for JEE mains level. So what I am suggesting, so solution chapter is over, and practice what we can say problems, which gives a lot of idea. So this is what I want to say from my side. So next class we have only two more chapters: chemical kinetics and electrochemistry and solid state. If I complete that, your complete physical part is over. So practice more and more problem. And thank you all the best.